So this is a typical benzene delocalized electrons, pi bonds, p orbitals type question. And before we start, if we go down and look at the mark scheme, the whole thing's worth 7 marks. 6 of those marks are for the content, but there's 1 for the quality of written communication, the QWC mark. To get that, you need to have 2 full sentences. Okay? I'm going to jot this down in bullet form, so I won't be using full sentences just to speed it up a bit. So the question says, describe with the aid of suitable diagrams, it's important, and it says diagrams, plural, the bonding and structure of the benzene molecule. So let's talk about the bonding first. And I'll write bonding as a subheading to make sure that I know what I'm up to. And let's draw our benzene out like this. So we have our carbon-carbon bonds forming a skeleton like this. And then we have our p orbitals going above and beyond the plane. Above and below, above and below, above and below. And remember what happens is the p orbitals overlap. So we say the p orbitals overlap. And then what we get is we get this type of thing where the carbon skeleton stays the same, but above and below the ring we have our pi cloud. So the p orbitals overlap above and below the ring, and it forms pi orbitals and what can we say about the electrons and that? We say that it forms pi orbitals with delocalized electrons. Okay, so that's the bonding done. We now need to talk about the structure. And there are lots and lots of things you can talk about in benzene about the structures. The first thing is, what can you say about the ring? So we say the ring is planar, it's flat. Next part, what can we say of the carbon-carbon bonds? So all the carbon-carbon bonds are the same length. And we go a bit further, we can say their bond length is intermediate between a carbon-carbon double bond and a carbon-carbon single bond. So all the carbon-carbon bonds are the same length, and it's intermediate between a carbon-carbon bond and a carbon-carbon single bond length. What can we say about the bonds between the carbons and between the carbon and the hydrogens? We can say those are sigma bonds. Sigma bonds between the CH and the CC. And the final point is, what can we say about the bond angles? Well, the bond angles are all, and the ring are all 120.